Have you ever looked up at the night sky and wondered how it all ends? Not just our lives or our planet, but everything. The stars, the galaxies, the very fabric of space and time. It's a mind-bending question, one that scientists have been wrestling with for decades. And today, we're going to dive into the most likely and most chilling scenarios for the ultimate fate of our universe. First, let's set the stage. We know our universe began with the Big Bang about 13.8 billion years ago. Since then, it's been expanding. Imagine a balloon with dots on it. As you blow up the balloon, the dots move farther apart. That's our universe. Galaxies are flying away from each other, and this expansion is actually accelerating. This acceleration is driven by a mysterious force called dark energy. And the ultimate fate of everything depends on the battle between gravity, which pulls things together, and dark energy, which pushes things apart. So, what are the leading theories? Let's start with the quietest, but perhaps the most profound ending, the heat death, also known as the Big Freeze. This is currently the most widely accepted scenario among physicists. In this future, the expansion driven by dark energy never stops. It just keeps going and going and going. Over billions, then trillions of years, the universe will become a vast, cold, and lonely place. First, galaxies will drift so far apart that the night sky in one galaxy will be completely empty of any others. Imagine looking up and seeing nothing but the stars in our own Milky Way with an endless black void beyond. Then, the stars themselves will begin to die out. All the fuel for star formation will be used up. The stars we see now will burn out one by one, becoming cold, dark remnants like white dwarfs, neutron stars, and black holes. The universe will slowly fade to black, like a city going dark, light by light. The age of starlight will be over, but it doesn't stop there. Over incomprehensibly long timescales, even these stellar remnants will decay. Protons themselves might decay, causing matter as we know it to dissolve into a bath of particles and radiation. Eventually, even the supermassive black holes at the centers of galaxies will evaporate through a process called Hawking radiation. After an almost infinite amount of time, the universe will reach a state of maximum entropy. Everything will be spread out, uniform, and at a temperature just fractions of a degree above absolute zero. There will be no structure, no change, no life, no thought, just a cold, dark, and eternal emptiness, a quiet final end. But what if dark energy behaves differently? What if it's not a constant force? This leads us to our second, more violent scenario, the Big Rip. Imagine dark energy getting stronger over time. The push of cosmic expansion would become so overwhelmingly powerful that it would tear everything apart. First, it would overcome the gravity holding galaxies together in clusters. Our own local group would be ripped asunder. Then, the force would be strong enough to overcome the gravity holding individual galaxies together. The Milky Way would be torn apart, its stars flung into the ever-expanding void. The terror doesn't stop. As the expansion continues to accelerate catastrophically, it would then overpower the gravity-holding solar systems together. The Earth would be ripped away from the Sun. Then the very chemical bonds holding our planet together would fail. The Earth would disintegrate. In the final frantic moments of the universe, the force would become strong enough to overcome the bonds holding atoms together. Matter itself would be ripped into its fundamental particles. Finally, in the last fraction of a second, the very fabric of space-time would be torn apart. The universe would end not with a whimper, but with a universal, catastrophic rip, a truly brutal and definitive end. Now, for a more cyclical idea, let's talk about the Big Crunch. This used to be a very popular theory. It's the exact opposite of the Big Bang. In this scenario, there's enough matter in the universe, or dark energy weakens and reverses, so that gravity eventually wins the cosmic tug-of-war. The expansion of the universe would slow down, halt, and then reverse. Galaxies would stop moving away from each other and start rushing towards each other. This would be a blue-shifted universe, where the light from distant galaxies will be shifted towards the blue end of the spectrum as they hurtle towards us. The cosmic microwave background radiation, the echo of the Big Bang, would heat up. The sky would grow brighter and hotter than the surface of the sun. As galaxies collide and merge, the universe would become a single scorching hot plasma. Eventually, everything would collapse back into an infinitely hot, infinitely dense singularity, just like the state before the Big Bang. What happens then? Some theories suggest this could lead to a big bounce. The singularity could rebound, triggering another Big Bang and creating a whole new universe. Our universe could be just one in an endless cycle of creation and destruction, a cosmic phoenix constantly reborn from its own ashes. It's a poetic idea, suggesting that the end is also a beginning. So, which one is it? The cold, lonely Big Freeze? The violent Big Rip? Or the cyclical Big Crunch? We gaze into the cosmos, wondering how it all will end. Will it expand forever, tear itself apart, or collapse back in on itself? The answer lies hidden in the cosmic shadows with two mysterious players, dark matter and dark energy. Let's focus on dark matter, the universe's invisible scaffolding. It's the gravitational glue holding galaxies together, preventing them from flying apart. So, does its gravity mean the universe will eventually stop expanding and crunch back down? Not so fast. While dark matter pulls things together, its counterpart, dark energy, is pushing everything apart at an accelerating rate. It's a cosmic tug-of-war for the fate of everything. The winner of this epic battle will decide the ultimate destiny of our universe. Have you ever wondered if our reality is the only one? What if beyond the stars we see, there are other universes, each with its own set of rules, its own history, its own version of you? This is the mind-bending idea of the multiverse. It suggests that our universe is just one bubble in a vast cosmic ocean of countless others. Some theories in physics, like string theory and cosmic inflation, point to this possibility. Imagine a universe where dinosaurs never went extinct, or where you made a different choice this morning, leading to a completely different life. The multiverse opens up a staggering expanse of what could be, transforming our understanding of existence itself. Have you ever wondered what came before the Big Bang? Or what will happen when our universe finally ends? The standard model tells us it all started from a single point and will expand forever until it fades into cold darkness. But what if that's not the whole story? What if the end is just a new beginning? This is the idea behind the Big Bounce theory. It suggests that our universe is just one in an endless cycle of creation and destruction. Instead of a singular Big Bang, there have been countless bangs and crunches. Our universe expands, then collapses back on itself under its own gravity, until it's squeezed into an infinitely dense point, only to explode outward again in a new Big Bang, an eternal cosmic dance of death and rebirth, forever and ever. Right now, the evidence points most strongly towards the Big Freeze. Our measurements of dark energy and the accelerating expansion of the universe fit this model best. The universe seems destined for a quiet, cold, and eternal slumber. But science is always evolving. We're still trying to understand the true nature of dark energy and dark matter, which together make up 95% of the universe. A new discovery could change everything. Perhaps there's a fourth, even stranger possibility we haven't even imagined yet. Thinking about the end of everything can feel overwhelming, even a little scary. But it's also a testament to the incredible power of the human mind. We are a tiny part of this vast cosmos, living on a small planet for a fleeting moment in cosmic time. And yet, we can use science and reason to ask these ultimate questions and piece together the story of our universe, from its fiery beginning to its potential final end. It reminds us how precious this moment is, this brief flicker of warmth and light in the grand cosmic story. So the next time you look up at the stars, remember the incredible journey they're on, and the profound mystery of where we're all headed. Thanks for joining me on this journey to the end of time. If you enjoyed this cosmic exploration, be sure to hit that like button and subscribe for more deep dives into the wonders of our universe. What do you think is out there? Let me know in the comments and subscribe for more cosmic journeys. Until next time, keep looking up.